Today we're going to be learning about electricity. I'm going to check what you guys remember from your reading. You guys should have all read about electricity for homework. So I'm going to check to see what you guys remember. Oh, it's broken. No. Okay, so what is the stuff inside this truck? What is this stuff inside of this truck? Lisa, what is this? What's all this black stuff?
Coal.
Coal. Coal. And what is coal? Does anyone know? Does anyone know what coal is? Taylor, what is coal?
I think it's like a rock or something.
Yeah, it's a rock. It's a rock and it's made mainly out of carbon. And people burn it. We burn it for energy. We burn it for energy. Okay, how do we turn coal into energy? Where do we take it? Where do we take it? Where does the coal have to go? Sam, where do we take the coal to turn it to energy?
I don't know the tower, that name, but I know what it look like. So that's like a three big silicone, and then it put gas out in the air.
Yeah, it's called a power plant. A power plant. Yeah, it's where we make the energy. It's where we make the energy. But I like your description. Yeah. It looks like a bunch of cones. Those are like yeah, it's just to reduce the amount of heat that escapes. Usually, guys, the coal is burnt and it spins a turbine, which makes the electricity. Okay, yeah, this is our power plant that he's describing. You see the cones.
But I don't like power plant because they make the air dirty.
They do make the air dirty. Coal, because it has to be burnt, is not very clean. It's not a okay. So we take the coal and we take coal trucks. Look how big that truck is. Look how big that truck is, and we take it to a power plant. How does it get from the power plant to your home? How does it get from the power plant to your home? Does anyone know?
But why do we need such a big truck? Not a simple truck.
Because a simple truck could not hold enough coal. This truck can hold about probably, I don't know, look how small this truck is. This is a normal truck. This is a normal truck.
Yep.
Right here. So this is much bigger. It can hold a lot more coal. Okay, guys, what do we use to get the electricity from the coal plant to your home? How does it get from here to here? Who knows? How does electricity travel from here to here? Ray.
People for they travel by wires. Electricity travel by wires from the power plant to the houses.
Ray's got it right. It's these electrical lines. It's these large wires. They travel. The electricity travels through the wire to your home. Through the wire to your home. Okay, let's read about it now. Let's read about it. Okay, you guys already read it for homework, but we're going to read it as a class. So turn to page 115 of your book. I will share your book on the screen now. It looks like this. Page 115. Electricity or electricity. It's electric. It's electric. Okay, who can read the first two sentences? The first two sentences. Let's have Moon. Moon, can you read us the first two sentences?
Electricity can make things move. Electricity is a form of energy. It comes to your home and I don't know how to speak that word.
Generating
generating
stations.
station. It travel
Very good. It travels through
It travels through the water to electrical outlet. It's your building ready to be used.
Yeah, it travels through these electrical outlets straight to where you can use it to charge your phone, your iPad, your computer. If you're using a computer right now, all this stuff requires electricity. Okay. I'll have a few more people read. We're gonna read it about 2 or 3 times. Alex, can you read it for us?
Yeah.
Thank you.
Electricity. It's electric. Electric can make things move. Electric is a form of energy. It comes to your home from energy generating stations. It travels through wire to earth in your building, ready to be used.
Ready to be used, yeah. And let's have one more person read. Let's have Emma. Can you read for us?
Energy. It's come to home to your home from energy
Generating.
generating
Yeah.
station. It's traveled through wires to electrical outlets in your building, ready to be used.
Good job. Good job reading, Emma. So guys, an energy generating station is just a power plant. It's on the right. This is an energy generating station. This is an energy generating station. Okay. They convert this into electricity, okay? So let's read each one. Who wants to read about coal? Banana, could you read coal for us? Banana, can you read about coal for us?
Coal is a fuel that can be burned.
Thank you, Banana. And Banana, do you know what a fossil fuel is? Do you know what a fossil fuel is? Raise your hand if you think you know what fossil fuel is. Taylor, what do you think a fossil fuel is?
Fossil fuel is I think that is underground and it's left back the coal.
Yeah, can you give me another example of a fossil fuel? So coal is a fossil fuel. Do you know any other type of fossil fuel?
Like plants or animal, when they die, they left back the bones.
Yeah. So
Or plants, they left print of the shape.
yes, that's a really good. You recognize the word fossil. The word fossil, guys. Guys, fossil fuels are old plants and animals that have died and been pressed down into rock. This used to be plants and animals from a long time ago, kind of like dinosaurs. And then we burn it for energy. This is like old plants and animals. Okay, especially like swamps. Swamps love to make, but it's a fossil, so we can't make any more. We cannot make any more. It takes thousands and thousands of years for coal to form, so we cannot make any more. Okay, who could read about the power plant for us? The power plant. Sophia, could you read the power plant for us?
This energy station heard from burning coal causes their forks to spin and
Generator.
generator.
Okay, and let's read about electrical lines. Let's have Sarah. Yeah, Sarah, can you read about electrical lines for us?
Electrical
Like this, like
Yes.
these, I mean.
like this carry electricity from the
Generating,
generating
station,
station across great
distances.
distances.
Yeah, Sarah, where are they trying to take the electricity? Where are they trying to take it with these lines? Where's the electricity going? Do you
I
think,
don't know of some.
where do you think the lines are going, Sarah? They're starting at the electricity, they're starting at the station. They're starting at the station, the power
They
station.
will go to
Where are they
many.
going?
They will go to many home or one.
Mm-hmm. They're gonna go to all these homes, Sarah. Good job. They're gonna go to all these homes. Okay, who can read about these homes for us? Let's read about the homes. Let's have Skart. Can you read for us, Skart?
Okay. Electrical lines like these carry electricity from generating station across great distances.
Okay, can you read the next one for us?
Electrical line like these carry electricity through the distances to home and business.
Yeah, Skart, have you ever seen these before? These lines that
Yeah.
travel? Yeah, they're all over Vietnam, huh?
Yeah.
There's tons of power lines.
Here I see have many.
Yeah, we have a
Many.
lot. We have many power lines.
Yeah.
So guys,
Maybe go around the world.
yeah, so guys, when I came from the US, the power lines are usually underground. They're under the ground. So when I came to Vietnam and I saw all of the power lines, it surprised me. We don't have a lot of power lines like this anymore. All of our power lines are underground. Okay. Who can learn about electrical meters for us? The electrical meter. Let's have Blue Moon. Can you read about it for us?
An electrical meter measures the amount of electricity used by the people inside buildings.
Yeah, and did you find one of these, Blue Moon? Were you able to find one of these? For
What?
homework? Did you find one of these in your building? An electrical meter? Were you able to find one? Have you ever seen this before in your building? The electrical meter?
Yes.
You have seen it?
Yeah.
Okay. I'm just wondering if you were able to find it. Where is it? Do you know where it is?
Yeah. Out of my house.
Yeah, mine's right outside my door. Mine is right outside
Yeah.
my door. And let's read the last, guys, this is the last one we need to read. What's this girl doing? What is this girl doing? Let's have Sarah. Or Funny, or Lucky, or Bunny. There you go. Can you read the?
Electrical wires inside a building carry electricity to each light switch and outlet in the building.
And do you have one of these in your room right now, Bunny? Bunny, do you have one of these in your room? Where's Bunny? There you go. Bunny, do you have one of these inside your room right now?
Yes.
How many? How many switches? 1, 2. I have 3. Mr. Connor has 3 in his room. How many do you have?
I have 4.
You have 4. What do they control? What do they control? What do the switches control?
The light in my room and the light on my table.
Okay, guys, type me in chat. What do they control? How many? Sarah has 5. Sarah has 5. Jackie has 5. Puppy has 2. Mr. Connor has 3. Someone has 20. What? Zook has 12. Kim has 9. That's a lot of switches. That's a lot of switches. I don't know if I believe all of these. That's a lot of switches. Okay. What you guys get for number 11? Who can read number 11 and answer? Choose the best answer to complete below. Type me in chat. How would we finish the sentence? Type me in chat. Let's see what we need to write. Electricity travels long distances through what? Oh, it's 6. Sarah has changed hers to 6. Electricity travels long distances through what? Electrical meters, generators, or high voltage lines? Type your answer for number 11 in chat. I'll call on the person that gets it first. Pasta was first. He got it correct. Anyone else have the answer? Type it in for number 11. Jackie got it correct. Good job, Jackie. Puppy got it. Puppy got it. Okay, let's have Pasta. Pasta was first. Pasta, what is the answer?
Electricity travels long distances through high voltage lines.
High voltage lines. Voltage is the flow, guys. Voltage is the flow of energy through the lines, the flow. That's voltage. If you're wondering what that word means, it's the flow of energy. Think about a river. Think about a river. The bigger the river, the higher the voltage. Okay, it's more energy flowing in a direction. It's like a large river, like a large river. So you guys can imagine these are like rivers, giant rivers, high voltage lines. These are like rivers. They kind of look like this. I'll show you guys, I'll draw you guys a picture. So these are high voltage lines. They're really big. They're really big. And they travel from the station to your home. So if we have your home over here, and these are our power plant, you have these high voltage lines, but usually this high voltage line doesn't travel to your home. Let's write 3 homes. I'll show you guys an example real quick. Home and a home. So usually it travels through a high voltage line like this. And then when it gets close to a city or a town, it switches over to these smaller wires. It switches over to these smaller wires you see in this picture right here. And these are not as high voltage. So let me draw that real quick. And it gets a lot thinner. The wires get smaller. And then they go to your home. It's like a river. And this is like a stream. This is like a stream. Okay. Format. Let's make my line a little bit bigger. Okay, evidence notebook. Suppose a storm knocks out one of the electrical lines in your neighborhood. What evidence from the pictures from page 115 and 116 explains why you would lose electricity? Why would you lose electricity if the storm knocks out one of your electrical lines? Puppy, why would we lose electricity if we have a storm that knocks out our lines? Puppy.
Yes.
Why would why would we not have electricity if a storm knocks out our electrical lines? What would why would we have no more electricity? So let's say there's a really rough storm and an electrical line going to your house gets destroyed. Why do you no longer have electricity?
Because the electrical line will fall down.
Yeah, it will fall down. Will it carry any more electricity from the power plant then?
No.
No. So it can't travel. The electricity can't travel. And then your house, the power goes out, and then you have to hope you have some candles. You need to have some candles if you want to have some light. Okay. Okay, Zook. Zook, were you able to find a meter in your house, an electrical meter in your house last night?
I don't have.
Were you able to find one last night?
No.
I didn't find.
You did not find. Okay, I want someone to raise their hand in their video if they found this electrical meter.
No, I don't have.
Okay, it's okay if you don't have it.
But my home,
Oh,
I have
but
to
I
go
know
to
the number.
Did anyone find this? Did anyone find this?
I cannot
I
find it, but I know the number. Just the number.
find.
Just the number. Okay. Who did find it?
No.
Mr. Connor.
Yes,
Mr. Connor.
yes.
I think Milk find it.
Zook found it?
Milk.
Milk. Okay, I'll
Yeah.
call on Milk.
Oh God.
Okay, Milk. Did you find it? Were you able to find it? Milk.
Oh.
Yes.
Okay, Milk.
So
What was the current number on it?
current number is
I don't. I can read this number.
Didn't have a number. Let me go check my number. I'll go check my number. Mine's right outside my door. Let me check it real quick. Mine was 23808. I'll check it after 1 minute. What do you guys gonna think is gonna happen to this number after 1 minute? Kim, what's gonna happen after 1 minute? What do you think?
the number will change.
Is it gonna change slowly or quickly? What's your prediction?
Quickly.
Quickly, okay? I'm gonna go check the number one more time. Let's see if it changed quickly. Okay, guys, it's 23808 still. It's the same number still. Do you think it's gonna change slowly or quickly? Now, Kim.
Now I think change slowly.
Yeah, we're gonna change slowly. It's still the same number. And then you'd write the number after 1 minute. Maybe it goes to 2380010.
Oh, good.
I'm just predicting, guys. I don't know how high it's gonna go. Oh, sorry. 0, 10. There. So guys, if it changes by 2 after 1 minute, how many is it gonna change by after 10 minutes? You can do the math. If it changed by 2 after 1 minute, what's gonna happen after 10 minutes? Jackie, what's the math? What do you think?
The math is
It changed by 2 after
Yeah,
1 minute.
But
So
I have another math. But I have another.
change by 2.
Like
What do you think is gonna happen after 10 minutes?
I think it's changed 10 more twos.
10 more 2s. So what's 10 times 2?
10 times 2 is let us think. 10 times 2 is
What's 10 times?
20.
Yeah, it's 20. So we're gonna add 20 to this number. So we're gonna do 238 0 28. I added 20 to this number. I added 20. You
Yeah,
gotta add 20 to this number.
but can you annotate me a little? I have another
Yeah, what was your number? What was your first number?
I don't know what. Can you annotate me a little?
Do what a little?
Yeah. Annotate me a little.
Oh, you want to annotate.
Yes.
Why are you gonna annotate? What was your number? Just say it out loud. I can write it down.
I don't have a number because my father said now it's like Corona. I can't go out my home.
Oh, you're not allowed to go out to look at the number. Okay.
But can you annotate me a little?
No.
I don't know. I have another
Yeah, because everyone's gonna draw if I can't make you, I can't just have you annotate, or I would, okay? Okay, guys, so that was your homework. Hopefully some of you guys did this. Guys, I was expecting you guys to do the meter reader. Everyone has one, even in you're supposed to do that for homework. You guys should have checked your meter. Everyone has a meter somewhere in their house, I think. I believe. Okay. Okay, let's take a quiz. Let's take a quiz. Let me share the screen. Oh, we need to write your vocab word. What was your vocab word? What was our new vocab word this class? You can tell me. What was our new vocab word this class? What was the yellow word? Let's make sure we write it down in a notebook. What was our vocab word? Taylor, what's our new vocab word?
T.
Electricity. Yep, electricity. That's our new vocab word. It is a form of energy. So guys, write this down somewhere or highlight it in your book Okay. Write down our definition, please. It is a form of energy. Okay, let's take a quiz. We're gonna start a live quiz. You guys, I'm gonna let you guys take it on your own. It's not gonna be the instructor one. You can take it on your own. Let me make sure all these are the same.
Team.
You wanna do teams?
Yep.
Okay.
3 teams or 2.
We'll do 2 teams. 2 teams. I'll split the class in half. Okay, let's get started. Let's continue. It's only 5 questions, guys. It's pretty short. This is the code. I will send the link though. I will send the link. Oh. Okay, let's see which team is going to be winning. The Dancing Slugs, Scarts on the Dancing Slugs, or the Brutish Bunnies, Okay, Ben 10, good job. You're on the Brutish Bunnies. Okay, let's start. I'm starting now, okay? We don't have much time left. I'm starting now. The Brutish, oh, it's getting closer. The Dancing Slugs are only a few points away. I think the Dancing Slugs can do it if they really try hard. Oh, it's neck and neck. You can look at my screen if you want to see who's the scores. Okay, the Brutish Bunnies have 7,000 more points right now. The Dancing Slugs, you got to go really, this is your chance to win. You got to go right now. Okay, we have our winner. The winner is the Brutish Bunnies with 42,840 points. Good job, Ray, Emma, Lucky, Moon. Oh, it went too fast. Let me look at the names again. Who was part of the Dancing Slugs? The Dancing Slugs were the Brutish Bunnies were first. If you were part of the Brutish Bunnies, good job. You were first. And the Dancing Slugs. Let's see what question. Oh, you guys did pretty good. 73% on the most missed questions. You guys did really good. Pasta got 100%. Pasta, Emma, Sam, Alex, Lucky, Ray, Zook, Ben 10, Scart, Sino, Taylor, Sophia. You all got 100%. Good job. You all got 100%. Good job. And Pasta had the highest score in the class with 5,800 points. Okay, guys, let me share the screen. Good job on the quiz, everyone. Oh, I don't need to share the screen. Your homework is to read about static electricity, pages 117 and 118.